There are discoveries that make headlines for a few days. There are discoveries that rewrite astronomy textbooks. And then there are discoveries so unexpected that they force scientists to question ideas that have shaped modern cosmology for decades. That is exactly the conversation sparked by the latest observations from the James Webb Space Telescope. For years, astronomers believed they had a fairly reliable picture of how the first galaxies appeared after the Big Bang. The earliest galaxies were expected to be tiny, faint collections of stars, slowly growing over hundreds of millions of years through mergers and continuous star formation. According to the Standard Model, the infant universe should have looked simple and chaotic. Instead, Webb looked farther into space, and therefore farther back in time, than any telescope before it. What it found surprised nearly everyone. Rather than seeing only small, immature galaxies, Webb revealed incredibly bright, compact, and surprisingly massive objects existing when the universe was still extremely young. Some appeared far more developed than existing theories predicted. Instead of cosmic infants, astronomers were staring at objects that looked strangely mature. These discoveries immediately triggered intense scientific debate. Were these galaxies somehow forming much faster than expected? Were our estimates of their masses incorrect? Or was there something about the early universe that existing models had overlooked? The questions multiplied with every new observation. One object in particular caught researchers' attention. At first glance, it looked like just another faint point of light buried among thousands of distant sources in Webb's deep field images. But detailed measurements revealed something remarkable. Its light had traveled for more than 13 billion years before reaching Earth. That meant astronomers were seeing the object as it existed only a few 100 million years after the Big Bang, a period when galaxies were expected to be just beginning to assemble. Yet this object appeared surprisingly luminous and unusually structured. Instead of resembling a chaotic cloud of newly forming stars, it looked more organized than theory predicted. Naturally, scientists questioned the data. Perhaps the distance had been miscalculated. Perhaps another nearby object was contaminating the observation. But spectroscopy, the technique used to measure an object's chemical fingerprints and precise distance, confirmed the astonishing result. The galaxy really was that ancient. And it was not alone. As Webb continued surveying the early universe, astronomers identified more and more distant galaxies displaying similar characteristics. Each new discovery challenged expectations a little further. Rather than finding only isolated anomalies, researchers began uncovering an entire population of unexpectedly bright galaxies existing much earlier than many theoretical models anticipated. That realization quickly became one of the biggest stories in modern astronomy. Deep field observations are designed to look into the distant universe, capturing light that has traveled across billions of years of cosmic history. Scientists expected these regions to reveal the universe during its earliest stages of development. Instead, Webb uncovered a surprisingly active cosmos. Many of these distant objects appeared compact, intensely bright, and rapidly producing stars. Some researchers proposed that early galaxies may simply have formed stars much more efficiently than previously believed. Others suggested that the masses of these galaxies might have been overestimated because the light from extremely young stars can make galaxies appear larger and brighter than they truly are. Either explanation would require significant adjustments to existing models. But neither fully solved every mystery. Several independent research teams continued reporting galaxies whose properties seemed difficult to reconcile with standard predictions. Rather than dismissing the observations, scientists began refining computer simulations to determine whether the early universe might naturally produce such objects under conditions not previously considered. This is how science progresses. Unexpected observations do not immediately destroy existing theories. Instead, they force researchers to test assumptions, improve models, and gather more evidence. And that is exactly where astronomy finds itself today. The James Webb Space Telescope has opened an entirely new observational window into cosmic history. For the first time, humanity can directly study galaxies that formed only a few 100 million years after the beginning of the observable universe. Each image contains clues about how the first stars ignited, how galaxies assembled, and how the cosmos evolved into the universe we see today. Every new observation answers one question while raising several more. And that may ultimately become Webb's greatest achievement, not providing all the answers, but revealing just how much remains to be discovered.